Researchers at MIT have developed a fully integrated robotic arm that fuses visual data from a camera and radio frequency RF information from an antenna to find and retrieve objects like keys even when they are buried under a pile and fully out of view. The researchers named it as R-Fusion. The R-Fusion prototype relies on RFID tags, which are cheap batteryless tags that can be stuck to an item and reflect signals sent by an antenna. Because RF signals can travel through most surfaces, like the amount of dirty laundry that may be obscuring the keys, R-Fusion is able to locate a tagged item within a pile. Using machine learning, the robotic arm automatically zeroes in on the object's exact location, moves the items on top of it, grasps the object, and verifies that it picked up the right thing. The camera, antenna, robotic arm, and AI are fully integrated, so R-Fusion can work in any environment without requiring a special setup. While finding lost keys is helpful, R-Fusion could have many broader applications in the future, like sorting through piles to fulfill orders in a warehouse, identifying and installing components in an auto manufacturing plant, or helping an elderly individual perform daily tasks in the home, though the current prototype isn't quite fast enough yet for these users. R-Fusion begins searching for an object using its antenna, which bounces signals off the RFID tag like sunlight being reflected off a mirror to identify a spherical area in which the tag is located. It combines that sphere with the camera input, which narrows down the object's location. For instance, the item can be located on an area of a table that is empty. But once the robot has a general idea of where the item is, it would need to swing its arm wildly around the room, taking additional measurements to come up with the exact location, which is slow and inefficient. The researchers used reinforcement learning to train a neural network that can optimize the robot's trajectory to the object. In reinforcement learning, the algorithm is trained through trial and error with a reward system. The researchers say that this is also how our brain learns. We get rewarded from our teachers, from our parents, from a computer game, etc. The same thing happens in reinforcement learning. We let the agent make mistakes or do something right, and then we punish or reward the network. This is how the network learns something that is really hard for it to model. In the case of R-Fusion, the optimization algorithm was rewarded when it limited the number of moves it had to make to localize the item and the distance it had to travel to pick it up. Once the system identifies the exact right spot, the neural network uses combined RF and visual information to predict how the robotic arm should grasp the object, including the angle of the hand and the width of the gripper, and whether it must remove other items first. It also scans the item's tag one last time to make sure it picked up the right object. The researchers tested R-Fusion in several different environments. They buried a keychain in a box full of clutter and hid a remote control under a pile of items on a couch. But if they fed all the camera data and RF measurements to the reinforcement learning algorithm, it would have overwhelmed the system. So, drawing on the method a GPS uses to consolidate data from satellites, they summarized the RF measurements and limited the visual data to the area right in front of the robot. Their approach worked well. R-Fusion had a 96% success rate when retrieving objects that were fully hidden under a pile. In the future, the researchers hope to increase the speed of the system so it can move smoothly rather than stopping periodically to take measurements. This would enable R-Fusion to be deployed in a fast-paced manufacturing or warehouse setting. Beyond its potential industrial uses, a system like this could even be incorporated into future smart homes to assist people with any number of household tasks. Every year, billions of RFID tags are used to identify objects in today's complex supply chains, including clothing and lots of other consumer goods. The R-Fusion approach points the way to autonomous robots that can dig through a pile of mixed items and sort them out using the data stored in the RFID tags much more efficiently than having to inspect each item individually, especially when the items look similar to a computer vision system.